Good morning students. Today we are going to learn about the topic is uniform circular motion. Uniform circular motion. Okay. First we can do one activity. Then you all know what is uniform circular motion. First you take a thread. One end of the thread is tied to the stone. Okay. So the other end is hold it. Now you can rotate the stone. You can rotate the stone. Now you observe the motion of the stone. Now what do you observe? The stone is rotated in the circular motion. Yes? Now you release the stone. What do you observe? The stone is moving along a straight line in the tangential in the circular path. Yes? Okay. In uniform circular motion, speed remains constant. Speed remains constant. But the velocity also changes. Velocity also changes. Okay. Why? What is velocity? Already you were studying in the previous class. Velocity is the vector quantity. Yes. It has both magnitude and direction. So the uniform circular motion is accelerated. Yes. We are going to study the definition of the uniform circular motion. When an object is moving with a constant speed, along a circular path, the velocity changes. What changes? The velocity changes due to the change in direction. Okay. Velocity changes, but the speed is constant. Speed is constant. The velocity also changes. Okay. It is called the uniform circular motion. What are the example of the circular motion? Example, Earth revolves around the sun and moon revolves around the sun. These are the example of the circular motion. When the object is moving in the circular path, the radius of the circular path is taken to one complete revolution. Okay. Now we can write the speed of the object. Already you know speed is equal to distance by time. Distance by time. But it is moving in the circular path. Yes. So speed is equal to circumference divided by time taken. Circumference divided by time taken. What's the formula of the circumference? 2 pi r. So speed is equal to v, velocity. So v is equal to 2 pi r divided by t. So in the uniform circular motion, the velocity v is equal to 2 pi r divided by t. Okay. We are going to study the centripetal acceleration and centripetal force. First we are going to study the centripetal acceleration. Okay. The same activity you are doing. Take a thread. One end of the thread is tied to the stone. Other end is hold it. Now you can rotate the stone. Now you observe the motion of the stone. Now what do you observe? The stone is rotated in the circular motion. Here the motion of the stone is circular path. Okay. Here also applying only one constant speed only applying here. But the direction only changes. So it is called the acceleration motion. Okay. Accelerated motion. So, in this case, an acceleration acting along the direction inwards. It is very important. Inwards, which makes the stone to move in the circular path. It is called what? Centripetal acceleration. Next, we are going to study the centripetal force. Okay, one force applying here, centripetal force. Force which act on the body to move along the circular path directed towards the center. It is very important. Towards the center. Here inwards. Okay. Towards the center. It is called what? Centripetal force. Centripetal force. Let us consider an object. Mass is m and it's moving with the circular path. The radius is r. Then velocity also v. What is the acceleration? Acceleration is equal to v square by r. A is acceleration, v is the velocity, r is the radius. Okay. So what's the formula? A is equal to v square by r. So the magnitude of the centripetal force is given by F is equal to mass into centripetal acceleration. Mass into centripetal acceleration. So F is equal to, mass is what? M. M into centripetal acceleration. What do you find out here? V square by R. So you are multiply the value F is equal to M V square by R. Do you understand clearly? Now we are going to study centrifugal force. Okay. One activity is given. Now you do one activity. From the activity we can understand the centrifugal force. Take a rope. One end of the rope is tied with a stone. Other end of the rope is hold it. Okay. Now you rotate the stone. The stone is moving along the circular motion. In the activity, one force is applied. What force? We can observe the pulling force. Pulling force, it is very important. From the center of the circle. Okay, so the pulling force is acting away from the center of the circle. But the centrifugal force is equal in the magnitude, but opposite to the direction of centripetal force. Okay, it is called what? Centrifugal force. What is centrifugal force? Force acting on a body away from the center. It is very important. Away from the center of the circular path is called centrifugal force. Okay, it is very important. What is the example of the centrifugal force? The dryer. The dryer in washing machine is an example for the centrifugal force. Already you are know. And merry-go-round rotating above the vertical axis. It is an example of centrifugal force. Okay. Now we can understand clearly the centripetal and centrifugal force. Okay. Next we are going to study the numerical problems. First one. A 900 kg car moving at 10 meter per second take a turn around a circle with a radius of 25 meter. Determine the acceleration. What do you find out? Acceleration and the net force acting upon the car. So what do you find out here? Acceleration and force. Okay, so it is moving in the circular path. So the radius is equal to 25 meter and 900 is what? Mass. Mass is equal to 900 and 10 meter per second. It is what? 10 meter per second. V, velocity. Velocity applying. So mass is 900 kg of car and velocity is 10 meter second power minus 1. What is the radius? It is moving in the circular path. So radius is 25 meter. What do you find out? The acceleration and force. Okay. So solution first you write. Solution. The car turns around the circle. So it is moving in the circular path. So what type of the acceleration is applying? Centripetal acceleration. Centripetal acceleration. Centripetal acceleration, the formula A is equal to B square by R. B square by R. So A equal to B is what? 10. 10 meter per second. So 10 square divided by radius is 25. Okay. So 10 square, 10 into 10 is equal to 100. 100 divided by 25. You are cancel it. The value is 4 meter second power minus 2 because what's the formula of the acceleration? A is equal to 4 meter second power minus 2. Okay. Next, what do you find out here? Acceleration. You are find out. Next, force. Force is equal to F is equal to ma. Here mass is 900 kg. So 900 into acceleration is 4. You are multiply with the value 3600 Newton. Okay. F is equal to 3600 Newton. What is the unit of the force? Newton. Yeah, racing car has a uniform acceleration. Uniform acceleration of 4 meter second power minus 2. What distance it cover in 10 second? 10 second after the start. Okay. First, do you know the equation of motion? The three equation of motion in the previous class you are studying. The explanation also. So first one is B is equal to U plus AT. Second, S is equal to UT plus half AT square. Third equation of motion is V square is equal to U square plus 2AS. Yes. Here, what are given here? Acceleration. A is equal to 4 meter second power minus 1. Yes. So first given acceleration A is equal to 4 meter second power minus 2. Now it covers in 10 seconds. So the time is 10 second. 10 second. Now you apply. You are find out the second equation of motion. Okay. S is equal to UT plus half AT square. Okay. So S is equal to UT plus half AT square. Here, what is the initial velocity? Initial velocity is 0. So U equal to 0. What is the unit of the distance? You are find out here. So S is equal to UT plus half AT square. Distance, yes. So S is, if you are find out this equation, S is equal to UT plus half AT square. Here, U equal to 0. 0 multiply time is 10 plus half into A. Acceleration is 4. Then T value is 10. So 10 into 10. 10 square. So 0 into any value 0 plus half into 4 into 10 into 10 100. Okay. So 2 2s are 4. So 2 into 100 is equal to 200. 200 meter. S is equal to 200 meter. What do you find it? What is the unit of the distance? Meter. Okay. So S is equal to 200 meter. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 meter and 20 seconds? So here listen, one complete rotation in the circular path. The diameter is 200 meter. How many seconds? 40 seconds. Okay. So what will be the distance covered and the displacement? It is very important. Displacement at the end of 2 meter and 20 seconds. So first part are given in the sum. First diameter is equal to how much? 20 meter. 200 meter. So radius is equal to R is equal to D by 2. So D is diameter by 2. So 200 divided by 2 equal to 100 meter. Okay. Time taken of one rotation. So time is time of one rotation. One rotation is equal to how many seconds? 40 seconds. 40 seconds. So time after 2 minutes and 20 seconds you are calculating. 2 minutes and 20 seconds. So 2 minutes and 20 seconds. 2 into 1 minute is equal to how many seconds? 60. So 60 seconds plus 20 seconds. Okay. So 2 into 60 is equal to 120. 20 plus 20 equal to 140 seconds. So distance, next distance after 140 second you are calculating. Next, what question? Displacement. Displacement after 140 second also calculate. Okay. So in the circular path the diameter is 200 meter. Here circular path, what's the formula? Circumference divided by time. What's the formula of circumference? 2 pi r. Here it is velocity. Velocity along a circular path. Okay, velocity along a circular path. So V is equal to 2 pi r divided by time. So 2 pi r into time is how many seconds? 40 seconds. 40 seconds. Okay. So 2 into pi value is 3.14 into r. R value is how much? 100. 100 divided by 40 equal to, you can multiply 314 multiply 2 is equal to 606.28 into 100 divided by 40 equal to 628. 6.28 multiply 100 is equal to 628 divided by 40. Now 2 2s are 0, 3, 1 2 is 4, 2s are 8, then 10, 1 2s are 2, 5 2s are 10, 7. So 157 divided by 10 is equal to 50.7 meter per second. So velocity is equal to 15.7 meter per second. Okay. Now you find out distance after 140 second. Okay, distance after 140 second. Distance after 140 seconds. So distance is equal to formula. Distance is equal to velocity multiply time. So what's the velocity? 15.7 into time is how many seconds? 140 seconds. 140 seconds. Okay. So your multiply, the value is 2198 meter because distance. What is the unit of distance? Meter. So distance is equal to 2198 meter. Okay. Next, you are calculate the value is displacement after 2 minutes and 20 seconds. 2 minutes and 20 seconds. So the total value is 140 seconds. Okay. So rotation next you are find out the rotation in 1 second is equal to 1 second is equal to 1 by 40. Rotation in 1 second is equal to 1 by 40. Here listen, time of one rotation is equal to 40 second. Okay, time of one rotation is equal to 40 second. So rotation in 1 second is equal to 1 divided by 40. So rotation in 140 second is equal to 1 divided by 40 into 140 equal to 3.5. So finally what do you write? In 3.5 rotation, outlet will be just at the opposite side of the circular track. Do you understand all the numerical problems. Okay, today class is over. Thank you.